Hey Nolan, I am going to do a quick look at that problem with the Ferris wheel. And just a quick reminder, so there's what y equals cosine of x looks like. There's what, terribly drawn, what y equals the sine of x looks like. They basically are the same shapes, they're just out of phase, they have different phases. We can model circular motion, which is what's going on with the Ferris wheel, using either sine or cosine. And typically what we want to do is pick sine or cosine so that it matches, so that it's easier. For example, we might have an easier phase shift depending on whether we pick sine or cosine, and that certainly is the case in this problem. I am going to figure out from this, the period, what b is going to be in this problem. And I know that the period is 40 seconds, and that's equal to our normal period for cosine, which is 2 pi over b. And if I solve that for b, I get b equals 2 pi over 40 or pi over 20, which is a little funky, but it is what it is. So b is pi over 20, and if we use, so here's what's going on in this case. We've got the Ferris wheel starting here, and then at t equals 0, starting at the bottom, and then it's gradually going up, and we want to find out when it gets to, what is it, 50 feet or something? Yeah, 50 feet, which is almost as high as it's going to get because it has a radius of 25 and it's starting at 30, so the highest it can get is 55. But we want to start it down here. It started at its lowest point. Well, cosine starts at its highest point. If we take negative cosine, then that's going to flip this guy over, and it's going to make it start at its lowest point. And this is going to track. If I pick cosine, my y value is going to go up slowly at first, and then it's going to go up quickly, and then it's going to go up slowly as it gets up there. And that's what cosine does. It starts going down slowly. Well, in this case, when I flip it over, it's going to start going up slowly. Then it's going to go up pretty fast in there, and then it's going to slow down as it reaches its peak. So if that makes sense to you, I want to use negative cosine. And my formula is going to be negative a cosine b. I'm going to call it t just because that goes with time, because our independent variable's time, minus some phase shift, plus d. But c equals 0 because we chose negative cosine so that there'd be no phase shift. Our amplitude is how far up and down it goes, and that is just our radius. So that is 25. And our d, as I already said, is 30. And our b is pi over 20. So we can stick all that junk into this template for our function. I should really put y equals there. And we're going to get y equals negative 25 cosine of pi over 20. No phase shift, so I can just go ahead and put t in there. Plus our vertical shift of 30. And then if I solve that, I don't think you have trouble with this. Well, let me go ahead and I'll do it all out. So we want the thing to be up to 50, and that equals negative 25 cosine this business plus 30. I'm going to subtract 30 from both sides, and I'm going to get 20. I'm going to divide by negative 25 too, and I'm going to get, just to start getting cosine by itself. I'm getting too low on the screen. So that's negative 20 over 25, which is equal to negative 4/5. equals cosine pi over 20 t. And I'm going to go ahead and erase some of the stuff up at the top so I have more room to work. And we're almost done with this problem. I'll go ahead and write it again. Negative 4/5 equals cosine of pi over 20 times t. And I can rewrite that as the inverse cosine of negative 4/5 equals pi over 20 times t. And if I get t by itself, I can say 20 over pi times the inverse cosine of negative 4/5 equals t. And if you put all that crud in your calculator, you get 15.9 seconds, which is almost half the period of 40. And that makes sense because we have gone from the bottom of the Ferris wheel up to our, this would really be our axis of oscillation at 30, I think. And we'd have gone all the way up to there, where that reaches 50 feet. So we expect that to be a little less than half the period, which 15.9 seconds is. And so that's our answer, 15.9 seconds. All right, Nolan, I'll talk to you in a little bit.